In science, it's crucial that you understand how to calculate an absolute error and also a percent error. What we generally are doing in science classes is we are trying to validate laws of science. So we'll do an experiment, we'll get some kind of a value, which is called our experimental value. You'll see that right here, experimental value. And then we're going to compare it to what we call a theoretical value, which would be a value that you would find in the textbook, or your teacher would tell you, here's what it's supposed to be, that has been, kind of proven over time. And we want to see how far off we are, or if we're really, really close and we did a good job proving that particular law. So the first thing that we can do is just calculate what we just a lot of times generally call the error, or what I like to call the absolute error. And it's very simple to do that. All you do is subtract the two values. Subtract your value that you got from the experiment and the value that is the theoretical value that you might have looked up in a textbook, or that your teacher gave you. Now, it doesn't matter the order in which you subtract them, because you'll notice here that we have these bars in our formula here. These are called absolute value bars. So no matter what, we're going to make it be positive. So generally what I tell my students is, whichever number is bigger, yours or the theoretical value, just start with that one and subtract the other value so that it's always positive. So to find the absolute error, I'm going to take the experimental minus the theoretical, or the theoretical minus the experimental, and that alone will be my absolute error. So let's say I have a theoretical value. Let's get a theoretical value of 24.6 something. Now in the experiment, I did this in the experiment, tried to figure out the value, and I might not have had as precise of equipment as scientists might have, and so I get an experimental value of just 22. It's not as precise as the theoretical value. I want to find, first of all, the absolute error. Well, the way I figure out the absolute error is I subtract these two values. And I already have them kind of in the order I want. I'm just going to take the bigger one and subtract the smaller one. So I'm going to take the theoretical value, subtract the one I got. And when I do that, on the calculator, it would say 0.6, to be 2.6. Now, the problem with this is that if you hopefully already watched the video and remember, what's the rule when we add or subtract measurements? Well, we only write our answer out to the least precise place. This one went to the tenths place, but this one only went to the ones place. So when I figure out my absolute error, I can't say my absolute error is 2.6 units. I have to say that it is 3 units apart. Now, it's very important that when you're doing percent error calculations that you calculate your absolute error first and go ahead and apply this subtracting adding rule to get 3, because your answer is not 2.6, it's 3. So that's for my absolute error. Now I want to figure out the percent error. And percent error is dividing your absolute error. It's basically taking your absolute error as a percentage of the theoretical value. How much is your error compared to the actual theoretical value. So you'll see up here we have experimental minus theoretical, but that's absolute error. So I can take absolute error, and divide it by the theoretical. And then I'm going to take that times 100, and by the way, 100 is a number, so I don't have to worry about measurement stuff with that. That's just a number, so I don't have to apply any rules there. So I'm going to take my absolute error, which I just got, which is not 2.6, it's 3. and I'm going to divide it by the theoretical value, which was this one here, 24.6, and I'm going to take that times 100. And if I do that on the calculator, 3 divided by 24.6 times 100, I get 12.1951. And I can keep going for a long ways, but you know you're not supposed to do that. You're supposed to round it off to the right number of sig figs. Well, how many sig figs do I have in my measurements? This one here has 3, and this one here has only 1. So you'll see how this can be kind of difficult, because to figure out percent error, you have to do absolute error first, and you have to do subtracting adding rule. Then you do percent error, and you do the multiplying dividing rule. So it's always important to do your absolute error and write it down, and then start over with your absolute error. So instead, because otherwise you'll trick yourself into thinking that this was it, and I would have 2 sig figs. Well, 3 is what I'm using, and I should have 1 sig fig, so I need to write this with only 1 sig fig, so that would end up being just 10. I'd have to round it to 1 sig fig. It'd be 10% is my error. 10% error. Okay, we need to try a couple more of these, I think. Let's say that I have a theoretical value. Theoretical value is 5.32, and my experimental value is 5.2. Okay, so let's figure out the absolute error first. I'm going to take 5.32 minus 5.2, and I get 0.1. Yeah, just 0.1. You might say 0.10, but I have to write my answer to the least precise place. This one goes to the tenths. This one went to the hundredths. So my answer can only go to the tenths. So there's my absolute error, 0.1. Now for my percent error, I want to take my absolute error, 0.1, and divide it by my theoretical value, which was the 5.32. Keep in mind, this up here it says experimental minus theoretical, but what I did was theoretical minus experimental. It doesn't matter which order you're actually doing that in. Keep that in mind. So 0.1 divided by 5.32 times 100 is going to give me, let's see, 0.1 divided by 5.32 times 100 gives me 1.87969, a whole bunch of numbers. So how do I write this percentage? Well, how many sig figs? I have 3 sig figs in this, but I only have 1 in that. So my final answer can only have 1 sig fig. So that means 1.879 is going to be 2%. 2% error is what we got in this experiment. That's my percent error. 0.1 is my absolute error. 2% is my percent error. Let's do one more. Let's take a theoretical value of 4.97 and an experimental value of 4.87. Okay, so I get my absolute error by subtracting these. So 4.97, which goes to the hundredths place, minus 4.87, which also goes to the hundredths place, which means my answer for absolute error is going to go to the hundredths place. It's a very easy problem. So I get 0.10. I must write that 0 down because it goes to that place. So there's my absolute error right there. Okay, so now my percent error means I take my absolute error, 0.10, divide by my theoretical value, divide by 4.97, and take it times 100. And if I do that, 0.10 divided by 4.97 times 100, I get 2.01207, a whole bunch of things. Your calculator doesn't know what you're doing. You need to know what you're doing. So you'll see here in this one I have 2 sig figs. In this one I have 3 sig figs. Remember, we're not worrying about the 100 because the 100 is a number. It's not a measurement, so we don't apply it. So I have 2 sig figs in this answer, so my percent error needs to have 2 sig figs. So it will be 2.0% error. So I have a percent error of 2.0%. My absolute error is 0.10. Very important that you always calculate your absolute error and write it down with the correct number of sig figs the way it's supposed to be. And then use that to go on and figure out your percent error. Hope that helps you out.